Download this code from codegive.com, link in the description below. Principal Component Analysis, PCA, to address multicollinearity. Introduction to multicollinearity. Multicollinearity refers to a situation in regression analysis where two or more independent variables are highly correlated. This can lead to unreliable and unstable estimates of regression coefficients, making it difficult to assess the individual impact of each variable. PCA is a dimensionality reduction technique that can help mitigate the effects of multicollinearity by transforming correlated variables into a smaller set of uncorrelated variables called principal components. What is PCA? Principal component analysis, PCA, is a statistical method that transforms a set of correlated variables into a set of linearly uncorrelated variables called principal components. This is done by identifying the directions, principal components, in which the data varies the most. Steps in PCA. 1. Standardize the data. PCA is sensitive to the scale of the data. Standardizing the data ensures that each variable contributes equally to the analysis. 2. Calculate the covariance matrix. This matrix shows the relationship between the variables. 3. Calculate the eigenvalues and eigenvectors. These determine the principal components. 4. Sort the eigenvalues and eigenvectors. This helps in understanding which principal components explain the most variance. 5. Select the principal components. Choose the top k components based on the explained variance. 6. Transform the data. Project the data onto the selected principal components. Implementation in Python. Let's implement PCA using Python with the sklearn library. We'll use a dataset with multicollinearity to illustrate how PCA can help. Example: PCA with a synthetic dataset. Explanation of the code. 1. Data creation. We create a synthetic dataset with 4 variables where x2 and x3 are correlated with x1. 2. Standardization. We standardize the dataset using standard scalar from sklearn. 3. Covariance matrix. We compute the covariance matrix to understand the relationships between variables. 4. PCA computation. We fit the PCA model to the scaled data, obtaining the principal components. 5. Explained variance plot. We plot the explained variance to decide how many principal components to keep. 6. Data transformation. Finally, we transform the original data into the PCA space and visualize the result. Conclusion. PCA is a powerful technique to address multicollinearity by transforming correlated features into a set of uncorrelated components. By analyzing the explained variance, you can decide how many principal components to retain, which can simplify your model and improve interpretability.